All right. I didn't grade the assignment yet. Some of them came in late last night, so I got to get the video out first, and I'll get put the grades up on the parent portal. All right, student portal, whatever. All right. Hope everyone's doing all right. We're nearing the end. Couple more topics, and then that's all I have. Unfortunately, okay. I'd like to cover more, but it's very difficult. I know you guys are doing really well. Okay. So we're working a little more with implicit differentiation. The two things we're going to do is finding a slope on a circle. So if you don't have this part of the notes, just copy this down. Okay. It's just this page and the next page. And then next week we're going to do a second derivative, just so I can introduce you to that. Okay. So find the slope of a circle, x squared plus y squared equals 25 at the point negative 3, 4. Okay. So remember what the slope is. The slope is the first derivative. Okay. So we have to use implicit differentiation. X squared, the derivative of x squared is 2x. The derivative of y squared is 2y dy dx. And the derivative of 25 is 0. Okay, so that's the derivative. 2x plus 2y dy dx equals 0. Now remember, when you're doing implicit differentiation, you have to get that term with the dy dx on the side by itself, and then get the dy dx by itself. So that means we're going to move the 2x over. Okay, there we have it. Let me do this. Okay, so we move the 2x over, and then we divide by 2y, and the 2's cancel. So the derivative of y with respect to x is negative x over y. Okay, remember that's the slope of any point, okay, on the circle. Okay, you just put it in wherever you want and you can find it. Slope of the tangent, right? All right, so what we do is we take those coordinates, plug them in, and let me extend the page here. Okay, so we plugged in, we have the negative 3 because it's negative 3, 4. So negative 3 over 4 gives you a slope of 3/4. Okay, and that is going to be one of the assignments that you have to do. Okay, or one of the problems on page 162. Okay, something exactly like this. Okay, now the next one. All right, so this is a little turn on it. Okay, little tricky question that you have to use, some prior knowledge. Okay, show that the slope is defined at every point on the graph. Okay, so 2y, you got to take the derivative. We're talking about slope again. So the derivative of 2y is 2 dy dx equals the derivative of x squared is 2x. And then derivative of sine y is cosine y. Okay, and then you have your dy dx. Okay, so yeah, the 2 dy dx equals 2x plus cosine y dy dx. That's the derivative. Okay, this up here, okay, is how you would derive it. So sine u, okay, we got to do the sine of u prime. Okay, remember that was old. So when you derive sine, it gives you cosine y. So you have the cosine y. Okay, and then the derivative of y is just 1. Okay, so that's where it comes from. All right, so then you have the dy dx. So now you have to get your dy dx's on a side, on the same side. So I think I brought the cosine over. Okay, so I subtracted cosine y dy dx. Okay, and now on the left side you have both terms with the dy dx. So what you have to do now is you have to factor it out. Okay, so you factor out the dy dx, and don't worry about this over here yet. Okay, so you factor out dy dx and you have 2 minus cosine y. Okay, and that equals 2x. So you have to get the dy dx by itself. So then you divide both sides by 2 minus cosine y. All right, and that's your derivative. So what you want to do is you want to show that this is defined at every point. So in order for it to be defined, that means that the denominator cannot equal 0. So we try to show where it happens. Okay, so we set that equal to 0. And if there is something that makes it 0, then that's where it will be undefined. Okay, but as we go through this, you see, you bring the 2 over, you're solving for cosine, and then look, you have cosine y, cosine y equals 2, that can never happen, okay? Because when you're looking at your range of cosine only goes from -1 to 1, okay? So since that is the case, it can never happen that the cosine of an angle will give you 2, so therefore it is always defined, okay? And that's how you would prove it, okay? So that's how you show the slope is defined at every point, okay? All right, now tangent and normal to an ellipse. Okay, look at this. All right, so again, we're getting a little more difficult. You should have these notes. Okay, same thing, we need to find the derivative. But now, as I underlined, you can see that we have a product rule within the implicit differentiation. Okay, so let's see how I did here. All right, so this is what I did. Okay, I step by step. So the derivative of x squared is your 2x. Now this subtraction, I leave it right out in front of the parentheses. So I will do the product rule and then I will distribute the negative. Okay, otherwise it gets confusing, especially when you get into trig derivatives where you have a cosine, which is going to be a negative sign, and and then you got a subtraction. So I just leave it out in front. So your xy, here it is right here. Okay, this is your product. So you have x, and then the derivative of it is 1. Y, the derivative is 1 dy dx. Okay, don't lose that dy dx. And then you have x dy dx plus y. That doesn't matter the order, okay? And then the derivative of y squared is 2y dy dx. Derivative of 5 is 0. Okay? So if you have to pause it and take a look where all those values came from, that's fine. Okay, and then I distribute the negative. Okay, distribute this negative right here. I distribute it through. Okay, and then what I did is I underlined the terms that have the dy dx in them. Okay, so what that means is I'm going to bring the 2x over and the y over to the right side. All right, just like that. And I got to move this over. Okay, so take a minute to look at that. So I added the y, I subtracted the 2x, and if you have negative 2x plus y, that's fine. And then, yeah, I just did 2y dy dx minus x. Sometimes people lose that negative in front of the x. Okay, then the next thing I'm going to do is I'm going to factor out the dy dx. Okay, so you have dy dx, and then you have 2y minus x equals y minus 2x. Then you're dividing by 2y minus x. So there is your derivative of y with respect to x. Your dy dx equals y minus 2x over 2y minus x. Okay? And remember, that's the slope of the tangent of any point. So we want to find it, the tangent and the normal to the ellipse. Okay, at the point 1, -2. So here we take the coordinate 1, -2, plug in for x, plug in for y. Okay? So I plugged in the 1 for x, the -2 for y, and I got a slope of 4/5. And then the tangent line is just like we've done in the past. Okay, the y equals mx minus x1 plus y1. Okay, but in this case is a -2 or a -2. Okay, and then there you go. And yep, go as far as you can. And there it is. Okay, so that's the tangent to the ellipse. Now the normal, remember, is perpendicular. So it's a negative reciprocal. So you just have, okay, -5/4. All right, and then x minus 1 minus 2, distribute through, and you end up with y equals -5/4 x minus 3/4. Okay, so there's your tangent and normal. All right, if you need to pause it, rewind, whatever you need to do. All right, so for homework. Okay, it is page 162. Okay. And you have the one where it says find the slope at the curve. So, number 9. Okay, because that's like the first example. And find where the slope of the curve is defined. Okay, you can try 13. And then the tangent and the normal. I think I just did that one. How about 19 and 21? 21 looks like a bear. Okay? But it won't be that bad once you get to it. Okay? So just be careful. All right? That'll be due Thursday. I'll put that out. If you have any questions or anything, shoot me an email or come to the Google Meet on Thursday. And that's it. All right. Good luck.